Now we will talk about how to solve quadratic equations using the quadratic formula. The quadratic formula, well, is a formula that works every single time whenever you want to solve a quadratic equation. And the quadratic formula comes from basically starting with a general quadratic equation. So suppose you have a quadratic equation and you have moved absolutely everything to the left-hand side of the equation and simplified. So you have 0 on the other side. And your variable is x, and a, b, and c are just numbers that you do know. So it could be 5, 7, 10, whatever. There's the a, b, c are not variables. They're constants. They're standing in here for numbers that you do know. You have them. You know those numbers. So you have this quadratic equation. If you apply the method of completing the square to this equation, you're going to get the solution. So if you apply the method of completing the square, you're going to get the solution to this equation. And the solution, you're going to find out after you do some algebra that the method gives you the answer, and the answer is this. So that means the method of completing the square actually applied to this general situation gives rise to this formula for x, which we know nowadays as the quadratic formula. Okay, so this b is the coefficient of the x, the a is the coefficient of the x squared, and the c is the constant term, the term doesn't have an x. The formula is x equals negative b plus or minus square root of b squared minus 4ac, all that over 2a. So that is the called quadratic formula. And that's the formula you really are supposed to memorize that. That formula is so basic that you really are expected to know it. And the formula works every time without exception. Okay? And actually, this part of the formula right here that is inside the square root, that the b squared minus 4ac, that has a special name, and it is called the discriminant of the polynomial a squared plus bx plus c. Okay, that radicand is called the discriminant, and the discriminant gives you information about the nature of the solutions and the number of them. So even without figuring out the actual solutions by just computing b squared minus 4ac and nothing else, absolutely nothing else, by computing the radicand and figuring out whether that's positive, 0, or negative, you can figure out the nature of the solutions, meaning are the solutions are going to be imaginary? Are they going to be complex? Are they going to be different? Are they going to be repeated? And so on. So this is the situation here. It's summarized in this table. When you compute the discriminant and you get a positive number for the discriminant, that means that there's going to be two different real solutions. Two solutions, both are real, and they're not the same, they're different. When the discriminant is 0, then is like, if you look at the formula, then is like this part of the formula is not there. Thus, when the discriminant is 0, then the radical part is not there. So that means there's no two possibilities, there's no plus or minus. So that means there's only one solution, namely negative b over 2a. That's the only solution. And it's repeated. So it has multiplicity too, as we had explained. It is a repeated real solution. And then when the discriminant is negative, what that means is that there's no real solutions, because if what you have is a negative number inside the square root, that means that you're dealing with imaginary numbers. You're dealing with complex numbers. So when this this thing inside the radical is negative, you're running into complex solutions. And you're going to get two different complex solutions. So the discriminant gives you information about what to expect even before solving the actual equation. Okay, so now let's apply the quadratic formula to solve a couple of examples. The quadratic formula is very easy to use. You just need to be careful that you're plugging in correctly the A, the B, and the C, and that you don't make any sign mistakes. Okay, so comparing with the general formula ax squared plus bx plus c, we see that the a should be 4 because the a is what is in front of the x squared. The b is 1. In this case, it is a coefficient of the x. And lastly, the c is the term without the variable, without the x. So the c is -3. So those are our a, b, and c. And we're going to plug these numbers into the quadratic formula. The quadratic formula being negative b plus or minus square root of b squared minus 4 times a times c, all that over 2a. Okay, so then b is 1, so that means this is -1 plus or minus the square root of b is 1, so this is going to be 1 squared minus 4 times a. A is 4 times c, and c is -3. -3, all that over 2 times a, and the a is 4, so 2 times 4 on bottom. Okay, and then we're going to simplify this. This is -1 plus or minus the square root of what? What is that? So this is 1 minus, well, what is this part? 4 times 4 is 16, times 3 is 48, but minus and a minus gives you positive. So this is 1 plus 48. All that over 2 times 4 is 8. So this is -1 plus or minus square root of 49. All that over 8. And now you get that this is -1 plus or minus 7. The square root of 49 is 7 over 8. Okay, and lastly, if you can simplify that a little bit, you should. And in this case, we're going to have to treat them separately. We have two possibilities. X is going to be, so you have the possibility of the plus and then the possibility of minus. X could be -1 plus 7 over 8, which is 6 over 8. And 6 over 8 is 3/4. And so that means 3/4 is a solution. And then the other possibility is a minus. So it could be -1 minus 7, all that over 8. -1 minus 7 is -8. -8 over 8 is -1. So that means the two solutions are 3/4 and -1. So two solutions are 3/4 and -1. Okay, and that's it. Now, in general, before we apply the quadratic formula, we do have to move everything to one side and have 0 on the other, just like this. Okay, like that. That's it. So the very first thing you need to do, in general, is going to be move everything to one side so you have 0 on the other one. in the first example that we just did, that was already done for us, so we didn't have to worry about that. But that's in general the first thing you need to do. Okay, now let's do the second one, B. So the first thing we need to do in this problem is we need to move everything to the left. So we need to move that negative 25 to the left before we can use the formula. So this is going to be x squared minus 3x plus 25 equals 0. Now we can use the formula. In comparing, right, the A would be the 9, the B would be negative 30, and the C would be this positive 25. So applying the formula, we're going to get negative, and then the B is negative 30 plus or minus the square root of, and then you have B squared. So this is negative 30 squared. Put the parentheses around the negative 30. Whenever you have a negative, you have to put the parentheses. Okay? Minus 4 times A is 9, times C is 25. Okay, all that over 2 times 2 times 9. Okay, now let's simplify this a little bit. Negative and negative gives you positive, so positive 30 plus or minus the square root of, and then you can put all that inside in the calculator. That is actually going to be 900 minus 900. Negative 30 squared is 900, and this part, if you compute it, 4 times 9 times 25 is 100. If you didn't have a calculator, you could do 4 times 25, that's 100, like 4 quarters is 100, and then times 9. 9 times 100 is 900. All that over 18. Okay, so simplifying more, you're going to get 30 plus or minus square root of 0 over 18. Okay, square root of 0 is 0, so that part we didn't write plus 0. We can just get rid of it. So that means this is 30 over 18, because adding, subtracting 0 doesn't do anything. And now we can simplify this further by dividing by what? 6. You divide by 6, you get 5 on top and 3 on bottom. So we get 5 over 3 as the only solution. Now, quadratic equations are always supposed to have two solutions. So this is the case here, this one. This is this case. Because the discriminant we actually found to be 0. The discriminant here was 0. So that means we have one solution and it is repeated. So that means this solution has multiplicity 2. So the answer is that this is x equals 5 over 3, and the multiplicity of this solution is 2, meaning it is repeated. Okay. Now we're going to do one more example. So it is this one. We're going to solve 2x times 3x minus x. 3 minus x equals 3. Okay. First thing we need to do is move everything to one side because we need 0 on the other side. We need 0 on the other side. And we also need to get that out of there. We need to distribute that. We need to get the x out of that inside, out of that parentheses. So we really do need to distribute this first off. So this is going to be 2x times 3 is 6x. And then 2x times negative x is negative 2x squared equals 3. Okay, now we're going to move the 3 to the left-hand side. We're going to write this in order. We need to write things in order. So writing things in order, writing the x squared part first, that's going to be negative 2x squared. You have positive 6x, and then we're going to move that to the left-hand side, the 3, and when you move it, it becomes negative 3. Okay. So now everything has been moved to the left, and we have 0 on the other side. So now we can use the quadratic formula on this. So quadratic formula tells us x equals negative b. The b is 6, so negative 6 plus or minus the square root of b squared. B is 6, so that would be 6 squared, minus 4 times a. A is negative 2 times c, and c is negative 3. Okay, a, negative 2, b is 6, c is negative 3. All that over 2 times a, and the a is negative 2, so over 2 times negative 2. Okay, now let's simplify. This is negative 6 plus or minus the square root. And what's that? 4 times 2 is 8. 8 times 3 is 24. So you would have 36 minus 24. You have 3 minuses, and 3 minuses multiplied gives you a negative, so negative 24. 36 minus 24, all that over negative 4. Alright, now simplifying further, this is negative 6 plus or minus the square root of 36 minus 24 is 12 over negative 4. Okay, now simplifying the square root of 12. The square root of 12 can be simplified by breaking the 12 into 4 and 3. The square root of 12 is square root of 4 times 3, that's square root of 4, square root of 3, and then square root of 4 is 2 square root of 3. So the square root of 12 simplifies as 2 square root of 3. So negative 6 plus or minus 2 square root of 3 over negative 4. Okay. Now, before we cancel, we can factor out a negative 2 from the top. This is going to be, you can do these separately, by the way. You can just do the plus first and then the negative first. But either way, this is how you simplify. You pull out the GCF, so that we're going to pull out a negative 2, and you're going to have a 3 here. So that negative 2 times positive 3 is negative 6. And then if there's two possibilities here, plus or minus, you're still going to have two possibilities here, plus or minus. And then this is going to be square root of 3. Okay, if you have two possibilities, plus or minus, by just pulling out a negative 2, you still have two possibilities. Pulling out a negative 2 does not like automatically or magically get rid of one of the possibilities. You still have two possibilities, the plus and the minus. So that's why you still put plus or minus there. And then on the bottom you have negative 4. And then we can cancel negative 2 from the top and from the bottom. Dividing both top and bottom by negative 2. So the negative 2 from the top goes away, and you would have 3 plus or minus square root of 3, all that over 2. I'm dividing by negative 2. And remember, you could enter these separately if required. Okay, and that's how you use the quadratic formula.